This video covers section 10.1, solving quadratic equations by completing the square. Objective 3, solve quadratic equations by completing the square. With completing the square, we will be able to solve all quadratic equations, not just factorable quadratic equations. Example 4, solve the equation by completing the square. Our goal is to write our equation in the form of the square of a binomial equals a number. We have to use our process of completing the square to obtain this square. So we saw that you take the coefficient of x and you divide it by 2, and then you square that number that you get in step 1. And we complete the square on the x squared and the x terms. So we're going to add 8 to both sides and disregard that for right now. The coefficient of x is 2. We divide that by 2 and get 1. And when we square that, we also get 1. So that's the term that we need to add here to make this the perfect square, x plus 1 squared. But by adding a 1 on the left side, I have to also add it on the right side to keep my equation unchanged. So that equals 9. Now we use the square root property to undo that perfect square that we made. So we have x plus 1 squared equals 9. And when I take the square root of both sides, using a plus or minus, I like that 9 there because that's 3. Plus or minus 3. And the left side is x plus 1. We subtract 1 from both sides. We have x is equal to negative 1 plus 3, which is 2. We have negative 1 minus 3, which is negative 4. When you get a nice perfect square underneath that radical, that means that this was factorable, x plus 4x minus 2. When you don't have a perfect square, then it meant that the original polynomial was not factorable. Okay, so we see that the first step is to isolate the x squared and the x terms. And so we achieve that by subtracting 9 from both sides. Once we do that, the first step is to take the coefficient of x and divide by 2. Then we square that number and get 16. That's the term that I have to add to make that a perfect square. But what I do to one side of the equation, I must also do to the other side. Now the left side is x minus 4 squared, and negative 9 plus 16 is 7. When this is not a perfect square, it meant that the original polynomial was not factorable. So we couldn't have solved it by factoring it. So we take the square root of both sides, remembering a plus or minus. That gives us x minus 4 equals plus or minus square root of 7. We add 4 to both sides, and we have 4 plus or minus square root of 7. And we leave the answer just like that. Here are 2 practice problems for you to try. I encourage you to press pause in your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. X squared plus 4x minus 12 equals 0. We isolate the x squared and the 4x terms. We leave a little blank spot there to see what we need to add to both sides of this equation to make it a perfect square. 4 divided by 2 is 2, and 2 squared is 4. So I'm adding a 4 on the left. I also add a 4 on the right. The left side is the square of x plus 2, and 12 plus 4 is 16. Perfect square means we're going to get some nice solutions. It meant that this factored. So we do x plus 2 equals plus or minus the square root of 16, which is 4. Subtracting 2 from both sides, we have negative 2 plus 4 is 2, and negative 2 minus 4 is negative 6. Perfect squares yield us some nice looking solutions, nice rational numbers. Letter B, we subtract 5 from both sides to get the x squared and the negative 2x by itself. We divide the coefficient of x by 2, which gives us negative 1. And then we square that number and get 1. And that's the piece that I need to add to make this a perfect square. But what I do to the left, I also do to the right. So I have x minus 1 squared on the left, and on the right I have negative 4. Now that's not a perfect square because of the negative. So we're not going to get the nice answers like 2, negative 6. And in fact, because it's negative, we're going to end up with complex solutions. I's. Because when I take the square root of both sides, I have 2i on the right, and on the left, x minus 1. Don't forget the plus or minus. So we add 1 to both sides, and we get 1 plus or minus 2i. So the problems we've just done had a 1 in front of the x squared. In example 5, we don't have 1s in front of the x squared. So if the coefficient of the square term is not 1, then before using the method of completing the square, divide each side of the equation by the coefficient of the square term so that it becomes 1. So since this is an equation, I can divide both sides by 3. That gets divided by 3, that by 3, and that by 3. Now we have the right-looking type of equation. We've got the coefficient of x squared is 1, and now we do the first step, which is to subtract 5/3 from both sides. Now we apply the process, divide the coefficient of x by 2, and square that number. That's the term that we have to add to both sides of this equation to make the left side a perfect square of x plus 1 squared. The right side is negative 5/3 plus 3/3, which is negative 2/3. So we don't have a perfect square on the right, and in fact it's negative, so we'll have imaginary solutions, or complex as we like to say. The square root of x plus 1 squared equals plus or minus the square root of negative 2/3. The left side is x plus 1. The right side is plus or minus square root of 2 over square root of 3i. Well, remember, with a square 3 in the denominator, we have to rationalize that by multiplying top and bottom by square root of 3. That gives you square root of 6 over 3i. And one last thing to do, subtract 1 from both sides. And we get negative 1 plus or minus square root of 6 over 3i. Letter B, we have to divide everything by 3 first. To make the coefficient of x squared 1. Zero divided by 3 is 0. Now we isolate the x squared and the x terms by subtracting 7/3 from both sides. Now we take the coefficient of x, which is 2/3, and we divide it by 2. When you divide a fraction by 2, you multiply by the reciprocal, which gives us 1/3. That's the first step. The second step was to square that number. And that's the piece that you must add to both sides of the equation to make the left side a perfect square. And remember, the number that you get in step 1 is the number that makes the perfect square. X plus 1/3 quantity squared. Now the right side, we have to get a common denominator. 9. So negative 7/3, top and bottom by 3 is negative 21/9 plus 1/9 is negative 20 over 9. Now we take the square root of both sides. And the left side is x plus 1/3. The right side is plus or minus. Square root of 9 is 3. Square root of negative 20 is an I that comes out. And 20 is 4 times 5, so that's 2 square root of 5. Now to solve for x, we subtract 1/3 from both sides. We can write the answer like that, or since they both have a denominator of 3, we could make one division bar. And here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. So we want to come along and get rid of the 2 in front of the x squared. We achieve this by dividing everything by 2. That gives me x squared plus 3x minus 1/2. We want to isolate the x squared and the 3x terms by adding 1/2 to both sides. Now we complete the square. Take the coefficient of x and divide by 2 and square that number. And that's the piece that we must add to make this a perfect square. What we do to the left, we also do to the right. The square that we made comes from the first step, x plus 3/2. The right side, we get a common denominator. 2 goes into 4 2 times. 2 times 1 is 2. 2 fourths plus 9 fourths is 11 fourths. Taking the square root of both sides, making sure to use a plus or minus, we get x plus 3/2 equals plus or minus square root of 11 over 2. Because the square root of 4 is 2. So then we subtract 3/2 from both sides. And we either leave the answer like that, or we write it as 1 division bar, negative 3 plus or minus square root of 11 over 2. Letter B, same thing, divide everything by 2 first, and get x squared minus 7/2 x plus 1. Isolate the x squared and the x terms by subtracting 1 from both sides. Now we take negative 7/2 and divide by 2, which is negative 7/2 times 1/2, which is negative 7 fourths. To figure out what this piece needs to be, we have to square that. So we add 49/16 to the left and add 49/16 to the right. The left side is hard to factor, so we remember that it's the first step that gives us the factor, x minus 7 fourths. Now we have negative 1 or negative 16 over 16 plus 49 over 16. And that gives us 33 over 16. Now I take the square root of both sides to get rid of that square and get my x out. And we get x minus 7 fourths out. And then we have plus or minus square root of 33 over 4. Solving for x, we add 7 fourths to both sides, which gives us 7 plus or minus square root of 33 over 4. So in summary, this solving by completing the square allows us to solve any quadratic equation. Some quadratic equations you solve end up giving you a perfect square on the right side, and you get these nice looking solutions that we would have been able to find by factoring. But if the right side is not a perfect square and it's positive, then you end up with these real number solutions, but they have the square roots in them. If the right side of the equation turns out to be negative once you complete the square, this is when we get the imaginary or non-real solutions. And those are the three different cases we will see when solving quadratic equations. And this concludes the video for section 10.1, solving quadratic equations by completing the square. Objective 3, solve quadratic equations by completing the square.